channel. In today's video lesson, we are going to be looking at likely post-utme question. Okay, so we are going to start with the first question. The first question for today is gotten from the topic called electrolysis. Now the question says two electrolytic cells, one containing copper 2 sulfate and the other containing silver nitrate solution. Now, if 10.76 grams of silver is deposited in the silver nitrate electrolyte, how much of Cu, which is copper, will be deposited in copper 2 tetraoxyl sulfate 6? Wow, if you come across this question in your exam, how do you solve it? First of all, you must identify the fact that the question is from where? Electrolysis, okay? And the calculation electrolysis boils down to the Faraday first and second law of electrolysis. Faraday first law of electrolysis has to do with just one electrolyte. Yeah, but in second law, in the Faraday second law of electrolysis, you have more than one electrolyte. It can be 2, it can be 3, as the case may be. Okay, now from this question you will find out that there are 2 electrolytes here. And what are the electrolytes? The first electrolyte is your CuSO4. This is the first electrolyte, and the second electrolyte is your silver nitrate. So when you have 2 electrolytes or more than 2 electrolytes in a setup, it means that the calculation is based on Faraday's second law of electrolysis. Okay, now what does the second law talks about? According to the second law of Faraday, it states that if the same quantity of electricity is passed through different electrolytes arranged in series, that is to say, both electrolytes must be in what? In series. Okay, he now said that the relative number of moles of the word ions deposited is inversely proportional to the charge on the ions of the element. So what are we talking about? According to Faraday's second law, according to Faraday's second law of electrolysis, according to the second law, it states that the number of moles that is deposited is inversely proportional to the charge. The charge here is talking about the oxidation state of the element, or the amount of electrons that it transferred for the atom to be deposited. So the number of moles is inversely proportional to the charge, which is the oxidation state. From there, you can see that according to Faraday's second law, you can find that the number of moles can be equals to your constant over the charge. Okay, now if you make constant subject formula, you are going to see that we're going to have K is equals to what? N times Q. Don't forget that. So this is Faraday's second law of electrolysis. Now, N is the number of moles. Q is the oxidation state of the metal, or the number of electrons needed to deposit 1 mole of the metal. Okay, so from here you can find that you have N1. You can find that you have N1 Q1 is equals to N2 Q2. This is according to Faraday's second law of electrolysis. Don't forget I told you that N is number of moles. And don't forget that number of moles is equals to mass, which is the mass deposited over what? Molar mass. That's capital letter N. Please, it must be noted that number of moles is mass over what? Molar mass. And if that is done, let us quickly substitute mass over molar mass into this second law, into this formula. See, this N1 will give us M1 over molar mass 1. So we are going to have M1, that's the mass of the first atom deposited, over the molar mass of the what? Of the first atom multiplied by the oxidation state of the first atom. Look at it. Number of moles is mass over molar mass. So if you do that, you have m over molar mass times this charge equals to m2 over molar mass 2 times the charge 2. Wow. So this is so interesting that this formula is used in what? Faraday's second law of what? Electrolysis. Please take note of this. This formula must be noted. This is the mass of the first atom deposited. This is the molar mass. And this is the oxidation state. Okay, now if you have this formula, how do we solve this question or subsequent question that you are likely to see in your exam? Let's do this quickly. Now, the two electrolytes here is copper sulfate and silver. If you take it carefully, you see that for copper, you have 2 electrons. Copper has oxidation state of 2. So, to balance copper, you need 2 electrons to deposit copper, as you can see. Then, your silver has an oxidation state of +1. So, you need 1 electron to deposit what? Silver. So, from this equation that is given, you will find out that the charge here for copper, which is the first guy, CuSO4, Q1 is equals to what? 2. Then what's the charge? Q2 is equals to what? 1. Wow, so interesting. They went further to tell us that if 10.76 grams of silver, so they have given us the mass of the other what? Element. Remember that this one is number 1, this guy is number 2. So for number 1, the mass, which is M1, is equals to, we don't know, okay? Because they said 10.76 grams of silver. So they not give us the mass of copper, 2 sulfates of copper, which is number 1. But they gave us that of silver, which is number 2. So number 1, we don't know. But number 2, we have what? 10.76 grams. Wow, so interesting. Don't forget I said copper is number 1, but silver is number 2. So they gave us the mass of silver. They don't give us the mass of copper. Now let's continue. What is the molar mass of the first guy, which is copper? They gave us here. Don't forget this one is constant. That will give you 64. What is the molar mass of the second guy? That will give us what? 108. So if you have all of these parameters, it means that you have gotten your answer to the question. Now let's solve this quickly. Remember, I told you that from Faraday's second law, M1 over the molar mass 1 times the charge is equals to M2 over the molar mass 2 times the what? Charge. So what is M1? We are looking for M1. Let's leave it that way. All over the molar mass of silver, of copper, which is the first guy, is 64. What is the charge of the first guy, copper? Q1 is equals to what? 2. Equals to the mass of, don't forget this one is for copper, while this is for what? Silver. M2, which is the mass of silver, is what? 10.76. Okay? Then what's the molar mass of silver? 108. The oxidation state of silver, which is number 2, is equals to what? 1. So let's do this carefully. M1 times 2, 2M1 over 64 equals to 10.76 over 108. So let's cross multiply. You have 2M1 times 108 equals to 10.76 times 64. We just cross multiply this way. So let's do it quickly. If you multiply these two, you are going to get, let's do 108 times 2. So you have 16, okay, 0, 1, then 216. So what we have here is 216M1 equals to, let's do this, 10.76 times 64. You have 688.64. So we divide both sides by 2 and 6, 2 and 6. So this cancel this. The mass of silver will be 288.64 divided by 216. 3.188. So you have 3.188, approximately equals to 3.2 grams. So this is the mass of copper that is deposited. Okay, so we'll quickly take the second question. Now let's take the second question. Which of the following are what pairs of isomers? Which of the following are pairs of isomers? Remember that isomers are two or more organic compounds with the same molecular formula but different structural formula. Okay? Now, isomers was gotten from isomerism. Don't forget that. In isomerism, two or more organic compounds possess the same molecular formula and we call them isomers, but they have different structural formula. Okay, and we have two major branches of isomerism. We have the structural isomerism, then we have stereoisomerism. You must understand that we have structural isomerism, we have stereo. In structural isomerism, we have what we call chain isomerism, we have position isomerism, then we have functional group isomerism. You must understand this, okay? Then in your stereoisomerism, we have the geometric isomerism. Then we have the optical isomerism. Please understand that. We have geometric isomerism, then we have the optical. The geometric isomerism is trans and cis. They are divided into two. We have trans and cis. While optical is divided into two as well, called anatomers and diastomers. Okay, now according to this question, they said which of the following are pairs of what isomers? Which of these two compounds have the same molecular formula but can be drawn in different possible ways? Okay, now let us do that quickly. Option A says 2-propanol and propanol. 2-propanol and propanol. Remember, this is a member of acanol. Why this is a member of acanol? Don't forget that. For acanol, you have arrow attached to OH. That's what we have. But for acanol, we have arrow COR. So if you watch very well, you will see that this guy contains a carbonyl, okay? But this contains OH. So they can never exist as words isomers. Take note, it must be noted. So that is rooted out. In option B, it said 1-propanol and methoxyethane. Methoxyethane. Now let's consider this. Propanol, like I told you, is arrow OH, okay? Methoxyethane is from ethers, which is arrow O arrow. That's what we have. So now let us consider this, please. Watch this carefully. If you want to write your 1-propanol, also called propan 1-or, you write it this way: C3H7OH. This is your propanol, okay? Now, if you want to write methoxyethane, methoxy, CH3O, C2H5. Let us count the number of carbon atoms in propanol. In propanol, you have 3 carbon atoms. In this methoxyethane, you have 1 plus 2 to give you 3. The hydrogen is what? 8. here you have, this is 7 plus 1, 8, and here you have 3 plus 5, 8. And then you have the same number of oxygen, 1 oxygen, 1 oxygen. So these two guys are what? Isomers. But this is what you have to note. It must be noted that one, acanol are isomers with ethers. Take note of that. They are both functional group isomers. They have the same molecular formula but different functional group. Take note. So that is why when you see an acanol, okay, and you see an ether, you must note that they are functional group isomers. So the answer to this question is word B. More also, take note of this, that acanoic acid is an isomer of ester. Esters. This is ethers, while this is esters. They are not the same, okay? Take note, I'll give you an example. Imagine the compound CH3COOH. This compound is called ethanoic acid. Ethanoic acid. How do we write it in the form of ester? We can do this. What do we call this compound? This compound is called methyl methanoate. Yeah. So if you watch very well, you will see that the number of carbon atom here is 2. This one is 2. Hydrogen 3 plus 1, 4. This one 3 plus 1, 4. Oxygen 2. Oxygen 2. That's how you have it. So take note that acanol and esters are isomers. Okay. So you have acanoic acid and esters. They are functional group isomers. Number 3. Acana and acanone are also functional group isomers. I'll give you an example. If you have CH3CHO, it's called ethanol. But if you have HCOCH3, it's called ethanol. So you see the one and you see the R. If you watch very well, they are the same. So these are functional group isomers. So the answer to this question is word B, okay? So we are going to take 2 more questions before we call it a day. Now let's take question number 3. An element B has 2 isotopes. 20, this one has a mass number of 20, atomic number of 10. This one has mass number of 22, atomic number of 10. Present in the ratio of 2:3. The relative atomic mass of B is what? How do you solve relative atomic mass from isotopic mixtures? Now, this is how we go. Relative atomic mass is equals to the mass of the first isotopes times the ratio of that isotopes plus the mass of the second isotopes multiplied by its own ratio, then you divide by the total ratio. So R1 plus what? R2. This is the formula that is used to determine the relative atomic mass from 2 or more isotopic mixtures. Okay, now this formula number 1, sometimes the question is given to you in percentage. Okay, so how do you solve it if it is given to you in percentage? That is, if the isotopes are if the abundance are in percentage, then we use relative atomic mass is equals to the mass of the first isotope multiplied by the abundance, this means abundance, plus the mass of the second isotope multiplied by its own abundance all over. Total abundance is always 100. Okay, so the question on isotopes that you are likely to see in your exam could either be in the form of ratio or in the form of abundance. Take note, where alpha is abundance. So when you see alpha 1, it means the abundance of that first isotopes. And when you see alpha 2, it means the abundance of the second isotopes. It can come like that, but total abundance is always 100. Now let's do this question number 3. Let's do that quickly. Now remember that the question is given to us in the form of ratio. So we are using this one, okay? If you watch, you will see that the mass here is 20 and its own ratio is 2. So you have 20 times 2, okay? Then the other mass here is what? 22, and the ratio is what? 3. So you have 20 times 3 all over the total ratio, which is what? 2 plus 3. So what do we have? 20 times 2 is 40. Okay, this is 22, please. 22 times 3 will give us 66. Okay, all over what? 5. So what do we have? 40 plus 66, 106 over 5. So 106 over 5 is likely to give us what? Let's calculate it. You have 5 going to here, you have 2. 5 going to 6, you have 1 remainder 1. Then when you put 0 on that, you have, wow, this is your answer, 21.2. Now, let me check it. So if you have 106 over 5, and that will give us 21.2. That's what we have, okay? Probably there's a mistake in the question. You have, let's believe that this is 21.2. So the answer is what? B. Finally, we have the group that oxygen belongs to is collectively called what? What is the name of the group that oxygen belongs to? First of all, remember that the periodic table is made up of 8 groups or 18 groups, okay, and 7 periods. What's the name given to group 1 element? Group 1 element is called alkaline metals. Don't forget that. Group 2 is called alkaline earth metals. Group 3 is called coinage metals. Group 4 is called crystallogens or cyanogens. Group 5 is called pnictogens or nigogens. Group 6 is called chalcogens. Group 7 is called halogens. Group 8 is called noble or rare gases. Don't forget that. These are the names given to the groups in the periodic table. Now, the group that oxygen belongs to is collectively called that. It is not ozonide, it's not halogen. Halogens are members of group 7. Oxygen is in group 6 of the periodic table. Remember, if you write oxygen this way, you have a mass number of 16, atomic number of what? 8. So you have 2, 6. It's found in group 6 of the periodic what? Table. So the group 6 elements are called the what? The chalcogens. So the answer to this question is what? C. Don't forget that members of the same group in the periodic table are known as cogeners. Okay, so the members of group 6 are cogeners. They are members. They are named as cogeners. Okay, and the name of that group is called the chalcogens. Thank you very much. We have come to the end of today's video lesson. If today is your first time for coming across my channel, do well to subscribe for more content. Thank you very much.